Hi, my name is Sebastian.
Hi, my name is Angela, and for our Project Zero Gold Point section, we made an eclipse simulator which calculated the date of every future eclipse, and Sebastian's going to talk about how we calculated when there was going to be an ellipse.
Yeah, so for making our eclipse calculator, what we did is first modify the planets.txt file, and we took out all the other planets. So Mercury, Venus, and Mars we didn't need because most eclipses only involve the Earth and the Moon. We don't really count all the other interferences as eclipses. So we took out all the other planets, we added in the Moon using the Pluto.gif file that was provided, and we set it in a stable orbit around the Earth using the variables in the .txt file. Then we modified the source code to store two variables, the vector between the Sun and the Moon and the vector between the Sun and the Earth. And to calculate an eclipse, we had to check two things. First, we had to check that the two vectors were parallel, that is, they were pointing in the same direction, and the Moon would block the Sun's light on the Earth. And we had to check that the Moon was in fact closer to the Sun than the Earth was, that is, it's not on the far side of the Earth. So storing these two variables, we used the distance functions we were provided and other ones we were able to calculate, and then use those in a couple of if statements for every time step to check whether it was in fact an eclipse. And Angela can talk about how we calculated the date of eclipses, converting that with our time step function.
Okay, so the two things that we needed for the date counter is the Earth's orbit, the length of the Earth's orbit, and also the time step between the two eclipses. So to calculate the time for the Earth's orbit, all we needed to do was to see when the Earth would cross the x-axis, because there starts on the x-axis for the simulation. So we simply just took when the y value or the y position went from a negative to a positive, and that would give us the length of one of Earth's orbits in the simulation. After, to calculate the date, we just needed to find the relative time in the simulation. So we get the time elapsed between the first ellipse, which is where the Earth starts, and the next one that happens. So we would simply use what we used to iterate with, the time step, and divide it by the length of the Earth's orbit in the simulation, and we multiplied that by the number of days in a year to just get the days elapsed between the first orbit and the second orbit. After, you imported two libraries, the calendar library and a simple date format library. And this way you can use the libraries to calculate exactly what the date is for the next eclipse. So all we needed to do after we calculated the date was to make the graphics for the simulation, and Sebastian can talk about how we did that.
Yeah, so as you can see on screen, the graphics for the final product were divided into three main areas, separated by some red lines. So on the left is your traditional N-body project that everyone worked with. We have the Sun and the Earth orbiting it, and if you look very closely, you could probably see the Moon very tightly on top of the Earth. However, at that scale, it's really unreasonable to see the Moon, and definitely can't see the Moon orbit. So what we did is a zoomed-in version of that in the top right, where the Earth is fixed, and it shows the Moon's position relative to the Earth at 125 times the scale density. So it's a bit of a microscope that's centered on the Earth and traveling with it. And then in the bottom right, we have a date counter that continues increasing as we increment our time step, and then it pauses when there's actually an eclipse. So this is really cool. We got to learn about how to use the standard draw library and a lot of the tools provided in it. We were able to change the screen size, draw lines, text, and all kinds of things that we didn't know were possible and very easily provided.